Let's have a look at this word problem. And here's a little child that is sick. And when we're sick, the body's main defense system is to raise the body temperature. And that's what this word problem is about. Let's have a look. If a 35 kilogram child has a temperature of 104 degrees Fahrenheit, or changed over to Celsius, 40 degrees Celsius, how much heat was needed to raise her temperature to that value from an initial value of 98.6? In other words, how much energy did the body use up or burn in order to raise her body temperature from 98 to 104 Fahrenheit, or 37 Celsius to 40 degrees Celsius? The equation we're going to use for this is Q is equal to Cm delta T. The value for C, or the heat capacity, is given to us here. For a typical body, it's been estimated to be 3,500 joules per kilogram Celsius degree. Let's write down a list of what is given. Or before I do that, let's expand delta T. Cm temperature final minus temperature initial. That's what delta T represents. And it's always in this order. Temperature final minus temperature initial. So back to what is given. Temperature final, we know, is going to be 40 degrees Celsius, and we're working in a metric system, so we'll stay with Celsius. And temperature initial is 37 degrees Celsius. The mass, this is the mass of the child, which was given us as 35 kilograms. C, as I just said earlier, estimated to be 3,500 joules per kilogram Celsius degree for the human body. And we want to find the heat energy that is being expended by the body in order to raise the temperature from 37 to 40. We have what we need, and we have the equation. All that's really left to do now is to input this data into our equation. And here we go. Q is equal to Cm delta T. And before I go any further, we can put this into perspective. Our body is mostly water. So if we were to use this graph, seeing our body is mostly water would be this portion of the graph. And the equation that is used for this sloping graph right here for heat energy is Q equals Cm delta T. Only that the C will be a different value. We look at our formula sheet. Different values for specific heat capacities for ice and water and steam. Well, we're none of these. So the estimation or estimated value of C for the human body is 3,500 joules per kilogram Celsius. If I replicate that diagram, so we're going from here, 37 degrees Celsius. This here is 0. There's 1 hertz. We're going to go from 37 up to 40 degrees Celsius. And the equation that represents that slope. So here we go. Putting in the numbers now, Q, amount of energy needed in order to raise the temperature, those are 3 degrees Celsius, is C, 3,500 joules per kilogram Celsius degree, times the mass of the child, times the two temperatures, subtraction of the two temperatures. Temperature final said was 40 degrees Celsius minus 37 degrees Celsius. When I subtract these two, it's going to be 3 degrees, but it'll be 3 Celsius degrees. And these drop out. When I make that subtraction, the unit will be Celsius degrees. Multiplying this and putting it in my calculator, Q is equal to 367,500 joules. Rounding this to significant figures, if we look here at the original word problem, I ignore temperatures for significant figures. You can see here, this one is in the 3 sig figs, and here we have 2. So I ignore temperatures, and we'll go something that's a little bit more solid for sig figs, and the weight of the child is given to us as 35 kilos. So we'll use 2 sig figs. Go to 2 sig figs here. So that's approximately 1, 2, go back up 1, 3.7. The decimal place is here, excuse me. 1, 2, 3, 4, 5 times 10 to the power of 5 joules. So there's our answer in joules. Well, let's take this a step further. And let's convert joules to calories. Calories is something we all understand. 1 calorie is equal to 4.186 joules. 1 little calorie is equal to 4.186 joules. So changing this value to calories, we put the value down that we know, 3.7 times 10 to the power of 5 joules times this conversion factor. Joules in the bottom, calories on top. These are little calories, as I call them, small letter C. 4.186. Oh, my mistake, 4.186 joules to 1 calorie. That way the joules cancel out. So taking that divided by this value, you get 88,389 calories. Rounding this into kilocalories, that's equal to 88,000, which is round down, or 88 kilocalories. Kilo meaning 1,000. Well, here's 1, 2, 3. There's 1,000. So it's 88,000 calories if I were to round down, or 88 kilocalories. And 88 kilocalories, this is the food calorie. The kilocalorie is the food calorie. So I can also call this as 88 capital letter C calories. This is the food calorie. Which is 1,000 times greater than the little calorie. And if we look at the chocolate bars, let's have a look-see here. And when we look at these labels, the energy that's given here in calories, well, this is actually the food calorie, capital letter C. This is actually 60,000 little calories, or 60 food calories. So 88 calories, food calories, represents about, since this one of these bars here is 60, so that would represent, let's see if I just take a bar out here. Having a little difficulty getting it out. There we go. So one of these represents 60 food calories. 60 food calories, or 60,000 little calories, as I call them. And if I wanted to replenish the body's consumption of 88 food calories, I just eat one of these, which is 60 calories. It'll be one, say 1 1/4 of these. 1 1/4 coffee crisps. So 88 calories being used up by the body to raise the temperature from 37 to 40 is about the same as eating 1 1/4 of these bars.